Hi guys, welcome to this chemistry session. Today we are going to deal with the Vsapr theory. Vsapr theory deals with the predicting the shape of any given molecule. So Vsapr stands for Valency Shell electron pair repulsion theory. So Valency Shell electron pair repulsion theory. So in this Vsapr theory, we are going to predict the shape of any given molecule. For example, let me take the simplest molecule as water. When I take water, it comprises of 2 hydrogen atoms and 1 oxygen atom. And let me consider oxygen as a central atom and hydrogen bonded to it. This is the we generally assume that water may be in this shape because it has an oxygen and 2 hydrogens, right? So oxygen is the central atom. So it says that in a polyatomic molecules, polyatomic means more than one atom. Here we have hydrogen and oxygen, so it is a polyatomic molecules. One atom is taken as the central atom and others atom are linked to it, right? So oxygen is taken as the central atom and hydrogens are linked to it. So the total number of Valency shell electron pairs decide the shape of the molecule. So let us understand what is this Valency shell electron pair. So this is oxygen. So we are going to just deal with the central atom. Based on the central atom, we are going to tell the shape of the molecule. How? Let us look into that matter now. So first let me write the electronic configuration of oxygen. See, we know that oxygen has 8 electrons, right? Oxygen has 8 electrons. The electronic configuration is 1s2, 2s2, 2p, 4. 2, 2, 4. 8 electrons, right? 1s2, 2s2, 2p, 4. The Valency shell. When I talk about Valency shell, what is the Valency shell? Let me take an nucleus over here. Let this be the K shell and let this be the L shell. K shell accommodates 2 electrons. So 2 electrons filled here. Now remaining 6 electrons. Out of 8 I have already filled 2. So there are 6 electrons remaining. So right. So those 6 electrons are filled in K shell. 1, 2, 3, 4, 5 and 6. Now I have filled the 6 electrons in the second, that is L shell, and I have completed the filling the 8 electrons. So this last shell is called as valence shell. This is the valence shell. Now this valence shell has 6 electrons, and if I draw the orbital diagram of filling electrons, so S orbital and this will be the P orbital. We know that each S orbital will have, or it can accommodate maximum 2 electrons. So 1, 2, 1, 2. This is 1s, this is 2s, and this is 2p. Now we have 4 electrons in p. So I will fill the electrons in this fashion. So I am filling the 4th electron in the first orbit. See, I could have filled in this way. This is not possible, but I am telling in this way. So there are 4 electrons, like 1, 2, 3, 4. I could have filled in this way also, but this is wrong. I have written in this way using the Hund's maximum multiplicity rule, which says that you can't afford to pair the electrons until each orbital are singly occupied. Why is it so? Because if I fill this half, if these orbitals are half filled, then it acquires maximum stability due to the symmetry. So we will deal it in the next some other video. We are going to deal with it. But for timing, I am going to use that principle. I am going to fill the 4th electron in this orbit. Now you can see that this is the second shell, this is the first shell. So this is the Valency shell I was talking about. Here are the 6 electrons, and I have 2, 4, 5, 6. Now you see that there is one unpaired electron, another unpaired electron, and I have a paired electron too. These unpaired electrons are going to play the role in the bonding along with the hydrogen that we are looking for. These two electrons are shared, one from hydrogen and another from oxygen. So one electron for this bond and another electron for this bond. The two electrons from the oxygen are released by these orbits, the unpaired electrons, right? These two electrons are going to form the lone pairs. So this is somewhat we thought initially, but the actual structure of water is not in this way. There is a slight change in the structure or the shape or geometry of water molecule. We are going to see how is it so. So this is done, right? There are two unpaired electrons and two lone pairs are present in oxygen, and these two lone pairs are present on oxygen atom. Now, by using this knowledge, we are going to deal with the structure. So this is the oxygen atom, and let me write the hydrogen like this itself. Now, if I know there are two lone pair on oxygen, so I will draw in this way, one lone pair and another lone pair. These are the lone pair of electrons. Lone pair, why is it called lone pair? Because it is present on single atom, so it is called lone pair of electrons. There are pair of electrons and also they are on the single atom, so it is called lone pair of electrons. And these are called as bonded. This is called bonded pair, this is called lone pair. Okay, now there are two lone pairs and also two bonded pairs, right? This is the total number of valence shell electron pairs. These are the shape of the molecule. 1, 2, 3, 4. There are two bonded pairs and two lone pairs. Now electron pairs orient themselves to decrease the repulsion and attain stability. These electron pairs, they orient themselves in such a manner that they try to decrease the repulsion. For example, let me consider in day-to-day life we see a magnet. It has a north pole. Magnet has a north pole and a south pole. If I imagine these two caps are the north poles and the tails of this marker are the south poles. If I bring north pole towards the north pole, there is a repulsion due to the Coulombic force of attraction and repulsion. If I bring again the tail ends, again there will be a repulsion. But if I bring a cap that is the north pole to the south pole, there will be an attraction. So the opposite poles attract and the same poles repel. In the same way, these both lone pairs are having electrons. Electrons are similar charges. Similar charges are going to move apart or they are going to repel with each other. There is going to be repulsion between these two lone pair of electrons. So the order of repulsion is in this way. Lone pair is greater than lone pair, bond pair, and lone bond pair repulsion is the least repulsion. This is the order. Now we see that there is a lone pair repulsion between these two lone pair of electrons. These are going to move away. So imagine if these are like this, then due to the repulsion they are going to move away from each other. Once if these two move away from each other, there will be again a lone pair bond pair interaction between this hydrogen oxygen and lone pairs. This bonded pair and lone pair, there will be repulsion. Here also there will be repulsion. Hence this bonded pair is made to move away from these lone pair. So it will be like hydrogens, both hydrogens along with the oxygen are like this. Due to the repulsion, they are made to move away. So there is a formation of bend. Like they are like this, they are made to bend. Okay. So now the structure they become is oxygen, this is hydrogen, and this is hydrogen. This is a lone pair and this is one more lone pair. Due to the lone pair interaction, we see that there is a structure is bent or there is a distortion in the structure. So that's what I told. The number of valency shell electron pairs decide the shape of the molecule. Now, because of interaction between these lone pair of electrons, the shape of this water molecule is decided. Vsapr can be applied to the resonance structures. If we have resonance structures, then we can apply this with Vsapr theory to those two. If the electron pairs are nearer, then the repulsion will increase. If these lone pairs are near to each other, then there will be repulsion increase. There will be increase in the repulsion. Once the repulsion increases, there will be energy increase in the molecule. If there is increase in the repulsion, the energy of the molecule gets excited. That is increase in the molecule, increase in the energy of the molecule. Once there is increase in the energy of the molecule becomes highly unstable. Hence, the stability decreases. Thus, these valency shell electron pairs try to orient themselves in such a manner that there will be least repulsion, and hence the stability of the molecule can be attained. Hence, we say that if the electron pair are away, if these electron pairs are away from each other, the repulsion is going to decrease obviously, and the energy of the molecules will also decrease. Hence, the stability of the molecule can be attained. Hence, the main aim or the theme of this Vsapr theory is to predict the shape or the geometry of the given molecule. Any molecule if you are given, if you apply this Vsapr theory, then we can easily predict the shape of the molecule. So, in this way, we can predict the shape of water molecule that is bent. See, it is bent. So, it is made to bend. So, initially, if I consider without this lone pair interaction, if I take a simple molecule, we initially assume that it is in this way. So it may be obviously somewhat 180 degree, like linear, but it is not the case. The bond angle decreases to 104.5 degree. There is a great decrease in the bond angle between hydrogen, oxygen, hydrogen. So this is due to the lone pair interaction. This is all about the Vsapr theory. That is the valency shell electron pair repulsion theory. So this order is the lone pair is highly repulsive. Then comes lone pair bond pair. This lone pair is, I would rank it first. So this will be the first, means it will be highly repulsive. Then comes lone pair bond pair. This comes the second, means they are repulsive but not as much as the lone pair. This comes to the bond pair. This is the third. So there will be repulsion but not as much as the bond pair and lone pair. So I wrote the order in as lone pair bond pair. So why is it so is these lone pair of electrons are present on the single atom, hence they require more space. Once they require more space, they are going to move away from each other. They require more space, hence they are going to move away from each other. Hence these bonded pairs are going to be compressed and there is a distortion in the shape of the molecule. This is how the Vsapr theory works. I hope you have enjoyed this session. If you have any doubts, you may comment it below. Thank you for watching. Have a nice day.